Lee Robinson from Vercel recently put out this awesome example of building an email client with the Next.js app router and Vercel Postgres. I wanted to see what this would look like using Supabase so I could easily integrate authentication, authorization, and real-time subscriptions. Let's get into it. Here I have Lee's version with this lovely 3-panel layout. And this feels very familiar and intuitive, which makes sense because it was built using Vercel's new AI UI builder thingo called V0. You can check out a link to that one in the description. So we can see a list of folders and then the emails that are currently in each of those folders. Each email has a subject, a sender, a receiver, the time it was sent, and then the body of the email itself. We can compose a new email, which we can send to an existing user like Alice, or we could send to a new user like alice2@example.com. And then if we give this a subject like testing new user and the body of hey, and then click send, we can see our new email has been sent. The recipient isn't actually correct, but we'll fix that later. And you can see both the data in the emails list column, as well as this count on our email folders have all been automatically revalidated, or fresh data has been automatically fetched so that our entire application reflects that new state. We can also delete that email, and we can see it's also gone from the other 2 panels. There's a link to Lee's video in the description where he goes much deeper into getting the project to this point. But let's get some Supabase happening. I don't have a Supabase project yet, so I'm going to head over to database.new and create a new one. This will ask you to sign in if you haven't created an account yet, but then we just need a name. I'm going to call mine email client, and then we can generate a secure password and then pick a region that's closest to the majority of our users. I'm currently the only user, so I'm going to pick Sydney, and then click this button to create our project. And while our project is spinning up, we can copy our Supabase URL and in our .env.local file, create a new variable for next _public _supabase _URL, and then we're going to want another one for our anon _key, which we can grab from our project, which is now up and running, so we just need to scroll down and we can copy our API key from here, and then paste that into our .env.local file. Now that our project is up and running, we can head over to the SQL editor where we can run raw SQL statements against our Postgres database. So Supabase is really just a collection of helpful tools that wrap around a Postgres database. So if we want our Supabase project to be the shape that our email client is expecting, we can just come over to the README here and copy and paste these SQL snippets to create the structure of our database. And we can just paste those into the SQL editor and click run, and success, no rows returned means everything was all good. And I can zoom in a little bit on this window so we can see we're just creating a table for our users, a table for our emails, and then our folders that we see on the left, our user folders, and then our email folders. And if we go over to the table editor, we can see that each of these tables has been created, but they are currently empty. So we can head back over to the README and then copy these statements to populate these tables with data. And again, we want to take these over to the SQL editor, and then we could replace the contents of this query, or we can just create a new query and paste it there. So we have a history of all of the SQL snippets we've run so far. And we can click run to populate our tables with data. And again, we can check the table editor and look at one of our tables, and we can see our sample data has been correctly inserted. We now have a Postgres database hosted by Supabase, which is in the same state as our Vercel Postgres instance that our application is currently using. So let's refactor our data fetching logic to use Supabase rather than our Vercel Postgres instance. Thankfully, Lee has designed this project in a very real-world, scalable, and secure way where he's grouped together all of the queries and actions under this DB folder, so keeping all of the database interaction logic for reading and writing in one place. Looking at this queries.ts file, we can see a bunch of raw SQL wrapped up in these functions that we're going to use throughout our application. And since this is just raw SQL, we can actually copy and paste this over to our SQL editor by creating a new query and then pasting in our SQL snippet. And if we run this one, we can see what the result of this query is. So it gives us back all of the folder names and then how many emails are in each folder. So if we scroll all the way to the bottom, we can see a really simple query where we're just selecting some columns from the users table. So let's start our refactor here. Firstly, we'll need to install supabase.js, which we can do by using pnpm install or I at supabase/supabase-js. I've broken this series of videos into 4 topics: fetching data, mutating data, authentication, and authorization. For these first two steps, we aren't going to be doing any user or session stuff, therefore we can just use supabase.js directly. But make sure you check out the other two videos to get this configured properly for auth, as this will require a few extra steps. There'll be a link to each of those videos down in the description. So let's create a Supabase client by calling the create client function, which comes in from supabase.js, and we need to pass this our Supabase URL and our Supabase anon key, so we can get those by saying process.env.next_public_supabase_URL, and then the same for our anon underscore key. And we'll chuck a bang here and here to tell TypeScript, all good, we will make sure that these values exist in every environment we're running in. Now we're probably going to want to create a Supabase client several times throughout our application. So let's create a helper function to make this a little bit easier. I'm going to create a new file under utils/supabase/index.ts, and we want to export a function. So we're going to say const. The name of our function will be create client, and then this is going to be equal to an arrow function, which we can implicitly return that block of code to create a new Supabase client, and we need to import this create client function from Supabase.js. Now there's a naming conflict between this create client and this new create client function that we're declaring, so we can just import this one as underscore create client and then return the result of calling that underscore create client function. Awesome, now we can forget about all of that config and just call our create client function, and we'll need to manually fix the import to instead come in from /utils/supabase. Now to actually refactor this query, we can get some data by awaiting a call to Supabase, and from the users table, we want to select the columns first underscore name, last underscore name, and email. And then we can return that data. Now TypeScript is telling us that data could either be an array of this shape or it could be null. So if it's null, we probably want to return an empty array. Now something to call out here is in the original example, this is being cast directly as a user email array. And so this isn't technically true, as this says we'll definitely get back a first name, last name, and email. But in our database schema, first name and last name are actually optional, or they can store a null value. Email is the only one of these columns which is not nullable, or a required field in the database. But just to keep this as close to the original as possible, we're going to return our data or an empty array as a user email array. I'll leave a link to a video in the description that shows how you can introspect your Postgres database and generate TypeScript definitions using Supabase. So this code is now unreachable, so we could just leave it, we could comment it out, or we could remove it entirely. So we can see our application is still working, and the bit that uses this function is when we're composing a new email, it's what populates this to field with existing users. So we can see that's working, and even further proof is that there is no Alice2 because our Supabase instance only contains the seed data from the README file. And so we're definitely pulling this data from Supabase rather than our Vercel Postgres instance. Let's take a look at a slightly more complex query. This one contains what's called an aggregate function, where we're grouping together a collection of rows into a single count field. And we can see the result of this query that we ran earlier, where we're getting back a list of folders and then how many emails are in each one. Supabase.js and the underlying Postgres package that powers these queries is not great at aggregates. We can do it, but this is an excellent opportunity to look at what to do when something is not supported by Supabase.js. So generally, I ask myself these two questions. Can this be solved with a view? If so, use a view. If not, use a Postgres function. We'll look at using views in this video, and then Postgres functions to perform transactions in the next one about mutations. So what is a view? Well, put simply, it's just a way to wrap up a query in a nice little box. This can really simplify our application code, so let's look at creating one, and then we'll come back to the theory side. Thankfully, Lee has already done all the hard work for us. We can just take this SQL statement and then wrap it in another SQL statement that creates a view. We could even use Supabase AI to say, create a view called folders with email count. And you'll see just based on the name of our view, Supabase AI has been able to put together pretty much the same query. So let's accept this change. And again, just to keep this as close as possible to Lee's version, let's replace this actual query with the one from our Next.js app. And we can format this one to make it a little bit nicer to look at. So we're creating a view with this name, and then the bit after this as keyword is the query we actually want to run. So again, that gives us this result set. So let's run this statement to create our view, and now we can treat this view as if it's just any other table in our database. So if we create a new query, we could select star from folders with email count, and we get back that exact same result set. But this statement is much simpler than this statement. And because we can treat this like any other table in our database, we don't lose that flexibility of being able to tag on a where clause. So we could say where email underscore count is greater than 0. So this will give us back only the folders that actually have an email in them. We can also filter down the columns that we're selecting. So we could say we just want to see the name. We could also order by name column and get this back in alphabetical order. Again, it's just like any table in our database. And that's the case with Supabase.js as well. So if we wanted to refactor this to use Supabase, firstly, we would need our Supabase client, which we can get by calling our create client function. We can then get some data by awaiting a call to Supabase, and then dot from our view. So that was folders with email count, and we want to select all of the columns. So this is the same as putting star here. And then this replaces that result. So now anywhere where we have result.rows, we instead want this to be our data. And again, this is telling us that this might not be an array, it could be null. So we could either use optional chaining here to say only perform the find and the filter if this is actually an array, or we can explicitly tell Supabase what this is going to return by chaining on a call to returns. And this is a generic function, so this takes in a type. So we're going to say this is our folder array, and then we just want to call that function. And we can now get rid of our optional chaining here, and you can see Supabase has correctly set that type if we actually get data back, but it's still warning us that we might not have data here. So we could leave our optional chaining, and then we could have a fallback if the find method doesn't exist. So if this isn't an array, we want to instead set this to an empty array. And let's add a little bit of space to make this a bit more readable that we're doing 3 distinct things here. So then for our other folders, again, we can use optional chaining and then set a fallback of an empty array. And now our special folders and our other folders are set to the correct type of a folder array. So as you can see, views are super flexible and they can really help clean up our application logic. You should use them whenever you can. Let's look at refactoring this next one. So this one's a little bit more complex. We've got multiple joins happening here. We're filtering down with this where clause, and we're also ordering by a particular column. Now this is just one branch of this function. So if search is undefined, this is the one we run. If we scroll down, we've got an almost identical base query, and then we're adding some additional filtering. And if we scroll a bit further, we can see again, very similar base query, and then some additional filtering. On inspecting this super closely, I realized the only thing that's actually different is this one joins the user's table on sender ID, this one joins it on recipient ID, and this one joins on recipient ID. I also noticed the README has this to do to fix to and from pulling sender and recipient everywhere, which I think means rather than the query getting back something that's in this kind of shape, where we have the fields from the emails table, and then these first name, last name, and email fields being dynamically set to either the sender or the recipient, we instead want to get back something that's in this kind of shape, where we have all of those columns from the emails table, but we're getting back this nested object for the sender and a separate nested object for the recipient. So wherever we call this function in our application, we get back all that information about the emails, as well as our full sender and recipient. We can also simplify this type a little bit further because we already have this user email type, which is first name, last name, and email. So both our sender and our recipient are of type user email. Okay, hopefully you followed along with that part. If not, just rewind it, watch it again. You can do that as many times as you want. Otherwise, let's go a little bit deeper with views and look at how we can use JSON to create these nested objects. So let's have a think how we want to break this down. This part of our query is essentially the same across all 3 branches once we refactor this joining logic. We'll do that in a second. But something we should consider is this where clause is filtering down by something that's dynamic. We also have this order by clause, which we may want to be different each time we call this view. So baking the dynamic parts of this query into the view doesn't really make sense. It kind of takes away from that flexibility of us being able to treat it like any other table in our database. And since we already know we can tack this onto the end of our query that's selecting data from that view, like we did over here when we were just selecting the name from our view and filtering it down to just folders with with emails and ordering them by a particular column, we can just take this top part of the query and wrap it in a view and specify all of this dynamic stuff when we're actually sending a query. So back over in the SQL editor, let's create a new query and let's say create the skeleton of a view called emails with folder and users. And Supabase AI has completely ignored us, thinking it knows better, which is fine. We can just replace the select all the way to the end of our query with that query from our application. Again, we can clean this up a little bit. This is technically correct, prepending the name of our view with the schema public, but we're not learning about schemas, we're learning about views, and it doesn't actually matter in this case, so we can just remove it. If you don't know what a schema is, just pretend you didn't see it. If you want to know what a schema is, we're about to release a whole bunch of Postgres theory videos on this channel, so let us know in the comments what you'd like to learn. But for now, we can just remove it. So we're creating a view called emails with folder and users, and then this is the query that we want to run, but rather than just joining the users table on this recipient ID, we also want to join the users table on sender ID. Now we can't have the same alias twice, because that doesn't make sense, so we can make this one R for recipient, and then we just need to change this to be the R.id, and then we could alias this one to be S for sender, joining on the S.id. And now rather than u.firstname, u.lastname, and u.email, we want everything from our recipient, so we can do .star, and we also want everything from our sender. Now if we try and run this, we're going to get an error that the ID column is specified more than once. So when we select the ID column for our recipient, that's overriding our email's ID, and then is immediately overwritten by our sender's ID. And this isn't really what we want anyway. We don't want this flat structure where everything's just coming back as a list of columns. We want to have a nested object for our recipient and a nested object for our sender. So we can do that by using the to_JSONB function, which is going to wrap up all of the columns of our recipient into a single JSONB column, which we can call recipient. We then want to do the same thing for our sender, and this one will be as sender. Now before we run this to create our view, if we have a look at this dynamic information that we want to be able to filter it on, we need access to the folder's name. And here we're just returning all of the columns from emails, all of the columns from recipient, and all of the columns from sender. So if we want to be able to filter on our folder's name, then that needs to be one of the columns that our view is returning. And we can alias this one to folder_name. And now if we run this query and then create a new query to select star from emails with folder and users, we can see we're getting back all of the columns from the emails table, and then this recipient column, which is a big JSON blob of all of our recipients information, and then the same for our sender, and we've also got the folder that that email belongs to. So let's refactor our application to make this request to Supabase and use this view. So again, we want to create a new Supabase client by calling the create client function. We then can get some data by awaiting a call to Supabase, and then from our new view, we want to select all the columns. And let's save that to do some formatting. So we've now taken care of this bit. We just need to filter this down for where there's a match on the folder_name column and this original folder name variable. And lastly, we want to order those results by the sent_date column. And the way we get descending is by passing it a configuration object where ascending is set to false. And again, to cast this as our type, rather than email with sender, this will be email with sender and receiver. So we can say .returns an email with sender and recipient array. And we need to call that function. We can then return data. Again, this could be an array of our type or null. So if it's null, we just want to return an empty array. And again, if we want our function to say that is the kind of type that's going to come back, we can say as an array of email with sender and recipient. Okay, another one down. Let's move on. If we have a look at the next query, it's checking if we're in the sent folder, then we want to join on recipient. Otherwise, we want to join on sender. And that's the only thing different between these two queries. And since we now get back both the sender and the recipient, this if statement is completely unnecessary. So let's collapse this down into one query. So let's get rid of this whole if statement and then this bit. So now we have this part of the query that's exactly the same as what's above, as well as this order by clause. So we just need to add this and condition with a collection of ors within it. So let's start by maybe moving our statement to create our Supabase client outside this if statement so we can use it for this query below. We then want exactly the same query, only we need to add a little bit more filtering logic right here. So in supabase-js syntax, by adding a match or any other kind of filter, these two get anded. Yes, anded is a word, so it basically has to match this condition and also match this condition. Now the second condition that we need to match is a collection of OR statements. So this may look a little bit intimidating, so let's break it down. This just means give me something that is like this condition, and I want it to be case insensitive, so I don't care whether it's uppercase or lowercase. These percentage symbols just mean any number of any character, as does this percentage symbol. So what this is saying is where the user's first name, whether it's uppercase or lowercase, is like or matches any number of whatever characters plus the search criteria that I'm actually looking for, and then any other number of whatever characters. So essentially any part of the first name column matches the search criteria that I'm looking for. And then this logic is just repeated for last name and email and subject and body. So essentially how you would expect a search box to work in an email client. So you want to be able to type part of a phrase, so part of someone's first name or part of the subject of the email, and you want it to be able to find it across any of those columns. So in our Supabase.js query, we want an OR filter, which is going to just be a big long string where we say we want our subject column to do an insensitive like comparison on any number of characters, and then our search query, and then any number of characters. We then do a comma, and then the next column, so that's going to be body, and then we want to do exactly the same comparison. Now copying and pasting this across every column we want to check is definitely going to end in a typo. So let's restructure this slightly so it's a little bit more clear. Let's create an OR filter above our query, which takes an array of columns that we want to do this comparison against. It then joins it with our comparison string, and lastly, joins that array into a big comma-separated string. And then we just need to specify each column that we want to run this comparison on. So currently it's running on subject and body. We also want to check the sender's first name, last name, and email, and the recipient's first name, last name, and email. So we can say recipient, which is our JSON-B column. We can then reach into that and access a particular property with this dash greater than symbol, and then specify first underscore name. We also want last underscore name, and also their email. We then want the same three columns for our sender, so we can just replace our recipient column with sender, and that's it. So this function checks if the user is currently trying to search something. If they're not, then it just gives them back all of the emails for that particular folder. Otherwise, it gives them back all of the emails for that particular folder where the search query matches any of these columns in our OR filter. And again, we can remove that original query, and we're down to our very last query to refactor. All right, this one's going to be a lot. Just kidding, it's almost exactly the same to our previous query, only we want to match our folder name and also the ID column with the value from email ID, which gets passed into this function. Now we're just trying to get back one email, which is definitely all our query will return because we're matching on ID, which is a primary key, meaning it's unique. So we can chain on a .single, giving us back just that one email with sender and recipient, rather than an array of email with sender and recipient with only one value in it. So down here, we can get rid of all this array stuff, and we can just say data as a email with sender and recipient, and that takes care of all of this. So we can do the super satisfying part of removing it. And this is still red, so we've obviously messed something up, but if we scroll up to the top, this is just because we have this unused import because we're no longer using Vercel Postgres. And there we go, all green, or I guess white or grayish color. Now we've written a lot of code. We haven't tested it works for a long time. Does it work? Moment of truth. Let's refresh. I was expecting it to blow up and be more dramatic, but it is still broken. Let me explain why. We're now missing all of the senders and recipients. And that's the case for over here in the from field of the email. And that's because we changed the structure of what a couple of these functions are returning. So get emails for folder now returns our emails with our sender and recipient, whereas before, remember, it was that flat structure where we were dynamically setting the first name, last name, and email of either the sender or the recipient. So we need to find anywhere we're calling this function, which is thankfully just in this one file. So we get back this emails variable, and then when we iterate over it down here, we're calling this format email string function, which is meant to take in a user email, which again are the fields first name, last name, and email. So rather than passing through our entire email variable, we need to determine whether this should be email.recipient or email.sender. And you'll see it's accepting either of those, the red goes away, all good. So this actually has slightly different behavior depending on which folder we're in. So if the folder name is equal to sent, then we want to display the recipient. Otherwise, we want to display the sender. So we can copy this here and change sender to recipient and save to do some formatting. So we've now moved that determining which one to show logic into our application rather than in the query that we're making to the database. This is now much clearer for anyone else working on this code base that if we're in the sent folder, then we're showing the recipient's name. Otherwise, we're showing the sender's name. The other one we changed in our queries was this get email in folder function. So again, we can search for anywhere that calls this and then go to that file. I suspect it's going to have the same problem. And if we scroll down, we can see that there's some logic here to say in the from field, either display me or call that same format email string function. So we know what that one does. And again, this is based on the folder name. So if we think this through, if we're in the sent folder, then the from should be me. Otherwise, if we're in any other folder like inbox, then the from field would display the sender's email. And then to reverse that for the to field, if we're in the sent folder, then we want to display the recipient's email. Otherwise, we want to show me. And if we save this one and go back to our application and refresh, just like magic, we're now seeing who each of our emails are from if we're in our inbox. And if we go to sent, we're seeing the recipient. And over here on the email, the to field is set to the recipient if we're in the sent folder. And if we go over to our inbox and look at this one from Alice, we can see the from field is Alice, who is the sender. Now that we've refactored our fetching logic to use Supabase, let's look at doing mutations. But for that one, you need to check out this video right here. We look at using Postgres functions to run a sequence of statements in a transaction to send a new email. But until next time, keep building cool stuff.